Businessman Peter Biantes has given why Albert Einstein's theory about the universe is mostly right. Business leader Peter Biantes is a corporate advisor who has achieved success in so many sectors. Peter is also an avid sportsman, science enthusiast, sports coach, and entrepreneur. According to Peter, scientists have proven Einstein's relativity theory to be true so many times. About Albert Einstein. Albert Einstein is a physics legend that thought beyond the present. He was born over 100 years ago. Einstein made relativity theories that defied the boundaries of that time. At that time, Pluto had not been discovered, nor do people think much about spaceflight and space travel. Still, Einstein didn't let that limit his works, imagination, and innovations. In 1915, Einstein made a publication about general relativity. He predicted some characteristics of the universe which were accurate, even nearly 150 years later. Albert's general relativity theory. Albert made a relativity theory that gravity is caused by space-time warp. It states the bigger the size of an object, the higher its chances of curving spacetime. Furthermore, the object has a higher chance of making objects smaller to it to fall in its direction. Furthermore, Einstein predicted that black holes exist. According to him, black holes are huge objects with high space-time warping ability that don't allow light to escape space. Other theories. Gravitational waves. Albert Einstein made a theory about gravitational waves, which are the huge ripples found in the space-time fabric. Besides, in the universe, when huge objects merge, they form gravitational waves. Moreover, it is easy to detect the wave with the use of an instrument called a laser interferometer. In 2015, scientists that observed gravitational waves asserted that gravitational waves exist, and they continue to detect more gravitational waves to date. A glass that magnifies gravitation. Albert said that an object that is big enough must have the ability to bend spacetime. Its bending ability should be enough to seemingly magnify the far-away light shown behind an object. This light should also be visible from Earth. The phenomenon explained above is known as gravitational lensing. Such a phenomenon is used in the deep universe to put up a magnifying glass close to an object extensively. Examples. James Webb's telescope for viewing space objects is an excellent example. The telescope is very famous for its efficient work and high-tech quality. It used the gravitational lensing phenomenon of a galaxy to create a deep field picture. This galaxy is billions of years away from us. Likewise, it also magnified galaxy clusters that are nearly 13 billion years far from planet Earth. Einstein ring. Because one lensing mentioned above was so clear, scientists acknowledged Einstein's part in discovering these galaxies. They put his name on one of the lensing. This is caused by the magnified light emitted from a far object that is shaped into a flawless halo-like shape close to a big object in the foreground. As a result, physicists called it Einstein's ring after Albert Einstein, says Peter Biantes. A star that frame drags. Einstein predicted that other objects bend spacetime close to those objects. This is proven by the extremely clustered lifeless stars' husks that bent spacetime. Scientists observed the way a neutron star goes around one dwarf. The star had been orbiting around the dwarf for 2 decades. How the neutron star and the dwarf orbit inspired the scientists It allowed the scientists to find a drift that will last long. Some physicists said that frame dragging caused the drift. Frame dragging is when a neutron star's orbit is a little altered by a white dwarf that pulls on spacetime. Thus, Einstein's relativity predictions were confirmed again. An orbiting spirograph star that dances. Einstein theorized that a superhuge black hole can be orbited by a star. Once the star completes 2 orbits around the black hole, in full, it will move. Instead of moving in an elliptical orbit, it will move forward in a dance-like pattern that looks like a rosette. The rosette movement that the orbiting star prefers is not fixed, unlike the elliptical movement. Thus, this is proof that Einstein was right when he said a tiny object revolves around an enormous object. Wobbly black holes. When you analyze gravitational waves, you can learn the secrets of enormous objects that discharge the waves. In 2022, scientists also studied the duo of binary black holes that slowly collided to release gravitational waves. This lets them know that as black holes move close to each other, they teeter in their trajectories. This is in line with Einstein's prediction made over 130 ago. Echoes of black holes. One of Einstein's theories about black holes was proven right by astronomers. They discovered that an unusual X-ray pattern was emitted close to a black hole that is millions of years away from Earth. Also, apart from the X-ray lights that flashed from the black hole's front, something else occurred. They heard the X-ray light coming from the back of the black hole echoing luminously. Even though the black hole's X-ray light is far from the Earth, people can still view it from Earth. According to entrepreneur Peter Biantes, this is because the black hole bent spacetime around the Earth.